topic is stoichiometricity and stoichiometric coefficient. Stoichiometric coefficient and stoichiometric metricity. What is stoichiometric coefficient? For example, whenever nitrogen react with nitrogen gas, react with hydrogen gas, then the formation of ammonia. To satisfy law of conservation of mass, we balance the chemical reaction. There is nitrogen, 2 atoms of nitrogen. This side only 1 atom, so we balance the nitrogen. Next, hydrogen having 2 atoms. In this side there is 6 atoms. This is balance. This 1, this 3, this 2 is known as stoichiometric coefficient. I am again repeating. When 1 mole of nitrogen react with 3 mole of hydrogen, then the formation of 2 mole of ammonia. These 1, 3 and 2 are known as stoichiometric coefficient. So the reaction becomes 1 mole of nitrogen react with 3 mole of hydrogen, then the formation of 2 mole of ammonia. This is known as stoichiometric coefficient. This 1, this 3, this 2 is known as stoichiometric coefficient. This stoichiometric coefficient helps us to find out the how much amount of reactant react. For example, there is 28 gram of nitrogen react with 6 gram of hydrogen, then the formation of 34 gram of ammonia. Again I am repeating that 28 gram of nitrogen react with 6 gram of hydrogen, then the formation of 34 gram of ammonia. The question arises, if I am having 14 gram of nitrogen and 3 gram of hydrogen, then what amount of ammonia formed? That time the formation of 17 gram. If I am having 7 gram of nitrogen, 1.5 gram of hydrogen, that time the formation is 6.5 gram of ammonia. Means this stoichiometricity helps us to finding out the amount of reactant and product in terms of gram. Okay, next example, if I am take that carbon solid react with oxygen gas, then the formation of CO2. It's 1 mole react with 1 mole of oxygen, then the formation of 1 mole of CO2. Then it's 12 gram react with 32 gram of oxygen, then the formation of 44 gram of ammonia. If I am having 6 gram, then I am required 16 gram of oxygen, then the formation of 22 gram. Is it clear? If I ask, if I am having 3 gram of carbon and 16 gram of, we are having 16 gram of oxygen, then what amount of carbon dioxide form? Again I am repeating. I am having 3 gram of carbon, 16 gram of oxygen, and how much amount of, some of you want to say that 19 gram. This is the wrong, because whenever we have 6 gram of carbon, that time we require 16 gram of what? Oxygen. Then the formation of 22 gram of carbon dioxide. But here we have 33 gram of carbon, but oxygen is 16. It means oxygen is present in excess amount. For 3 gram of carbon, we require 8 gram of oxygen. 3 gram of carbon required 8 gram of oxygen. Means this oxygen is present in excess. So this is known as excess reagent. And this carbon is known as limiting reagent. This is known as limiting reagent. This is known as limiting reagent. So how much amount of CO2 formed? If 12 gram gives you 44 gram of CO2, then 1 gram gives you 44 divided by 12. and 3 grams gives you, multiply by 3, 3 fours are 12, that gives you the 11 gram of CO2. Means by the help of stoichiometricity we can calculate the limiting reagent or excess reagent. Limiting reagent, the reagent which present in less amount in a reaction. I am again telling the limiting reagent which present in less amount, and the excess reagent is the reagent which present in excess amount. We are taking one more example. I am having nitrogen gas and 3 mole of hydrogen, then the formation of ammonia, 2 mole. Then you have to calculate. If I am writing this reaction in terms of gram, 28 gram react with 6 gram, then the formation of 34 gram. Is it clear? Okay. How much? Now listen to the question. How much gram of ammonia form? How much gram of ammonia form if you have 1000 gram of nitrogen? If we have 1000 gram of nitrogen, then how much amount of ammonia form? 28 gram of nitrogen form. How much? 34 gram. 1 form. 34 divided by 28 and 1000. We can calculate the amount of ammonia form. We having 1000 gram of nitrogen. We having 28 gram of nitrogen. That time the formation of 34 gram of ammonia. If we having 1 gram of nitrogen, that time how much amount form? That is 34 gram divided by 28. Now the question is saying that you having 1000 gram of nitrogen. So 34 divided by 28 multiply by 1000. This is the amount we get. For example, if we calculate this, 34 divided by 28, that is 1.214 multiplied by 1000. It means if we remove the point, this is 1000 and 1000 cancel out the 1000, that is 1214 gram of ammonia. If we having 1000 gram of nitrogen, that time we can form 1214 gram of ammonia. By the stoichiometricity, we can calculate the amount of different reactant and product which we have. Next, if we have 1000 gram of nitrogen and 2000 gram of hydrogen, then how much amount we require? Then how much amount we form ammonia? Again the question, we have 1000 nitrogen and 2000 hydrogen. First, how much amount of nitrogen form? How much amount of ammonia form? Okay. In this question, we have 1000 gram of nitrogen and 2000 gram of hydrogen. They are asking how much amount of ammonia. Okay. If we have 6 gram, that we require 3 times of nitrogen. If we have 200 gram of hydrogen, that time we require 6000 gram of nitrogen approx. It means this present in excess and this present in limiting amount. So this is considered as limiting reagent. Limiting reagent. Limiting reagent are those which present in limited amount in a reaction. How much amount of ammonia form? As we know, 28 gram of nitrogen form 34 gram of ammonia. 34 gram of ammonia. If we have 1 gram of nitrogen, that time 34 divided by 28 and this time we having 1000 gram of nitrogen. Then multiply by 1000, it again becomes 1214 gram of ammonia. And this nitrogen is considered as limiting reagent, and this hydrogen is considered as excess reagent. Okay, this is the last point. Stoichiometricity tells us about the how much number of moles react in a reaction. Stoichiometricity, we can say the balancing coefficient. If we are taking one more example, for example, hydrogen gas react with oxygen gas, then the formation of water molecule. According to the law of conservation of mass, the mass of reactant is always is equal to the mass of product. Here we having 2 atoms of hydrogen. In product side, we also having the 2 atoms of hydrogen. But in case of oxygen, we having 2 atoms on reactant side, but we having only 1 atom on the product side. Then what we'll do? This is multiplied by 2. If this is multiplied by 2, then the hydrogen atom becomes 4 at the product side, but at the reactant side this is 2. By balancing this 2, this 1 and this 2 is known as stoichiometric coefficient. And this stoichiometric coefficient is very important. That tells us about the amount, that tells us about the number of moles which react and how much number of mole is form of product. Okay.